Stretching and bending vibrations for the NH bond. Like OH, the NH bond is also polar, and therefore they're also going to exhibit a strong, intense absorption band. And they're also going to produce the absorption band about the same region as the OH. So that is about 3,300 to 3,000 centimeter inverse. But they can be clearly distinguished from OH stretches because they are going to be generally weaker and sharper than the OH band. Weak and sharp. Now, whenever you have primary amine, like what you see in this case, it's always going to give us two peaks for the NH stretch. One is for the asymmetric stretch, and the other one is for the symmetric stretch. So in the case of primary amine, you will see two peaks, one corresponding for the symmetric stretch, and the other one for the asymmetric stretch. But in the case of secondary amine, you only see one peak. And in the case of tertiary amine, there will not be any peak present because we do not have any hydrogen connected to the tertiary nitrogen, right? And when it comes to the bending vibrations, there should be a peak around 1,650 to 1580 centimeter inverse corresponding for the NH bend. Now this should not be confused with the C double bond O peak, C double bond O stretching vibrations, which normally appears about the same region, because generally this is going to appear as a sharp peak, sharp and also more intense peak, whereas the NH bend is normally going to be broadened and it's going to be weaker. And this NH bend is only present in the primary amine. It's not going to be present in the secondary amine or the tertiary amines. It's not going to be present. Now there is one important thing, there is one unique thing about this compound. This compound has two methyl groups connected to the same carbon. In which case you should be able to see two peaks on the right side of 1400. So here is 1400. Yes, you are able to see two peaks in that region. So this is a good indication that you have two methyl groups that is connected to the same carbon.